Right, good morning, learners. In this video, we are looking at, this is the first video of a series, looking at the grade 11 analytical geometry. So we're going to start in this video with lesson 1, the revision of the grade 10 concepts. Okay, so the grade 10 analytical geometry, it's not a lot and it's not difficult. So what you learned is, in grade 10, is to work out the distance between 2 points. Using the distance formula. There it is. So the distance formula says that the distance between 2 points A and B on a Cartesian plane can be found by taking the square root of the x value at B minus the x value at A squared plus the y value at B minus the y value at A squared, and then that is what you use to calculate the distance between 2 points. I'll show you now with an example how to calculate using this formula, but this is the first formula and you must know these 3 formulas. So the distance formula. The second formula is the midpoint formula that says that the midpoint coordinates x of the midpoint, y of the midpoint. So the coordinates of a midpoint I get by taking xb plus xa over 2 and yb plus ya over 2. This is, you substitute into the like a set of coordinates the values, and then you work out the midpoint between 2 points, and then you have the gradient formula, which also worked with in grade 9. So I think most of you is very familiar with the gradient, difference in y over difference in x. The gradient of a line that goes through the points A and B will be yb minus ya over xb minus xa. Right, so these are the 3 formulas that we're going to work with: distance, midpoint, and gradient. And you should know the 3 formulas and know which one is which. All right, and then we're going to start here with, I'm working from the Mind Action Series textbook. We're going to start here with this revision exercise. Question 1 that says, determine the length of the line segment joining each pair of points. So the length, I'm going to use the distance formula. Let's do question A and C here, then you can do number B and D on your own. So number A is the length of the line segment joining A and B that goes A. I'm just going to write it here as well. A is the point 1 minus 4 and B is the point negative 2, negative 7. Right. A and B is the point negative 2, negative 7. Right. So I'm going to use the distance formula. The distance formula looks like this. It says AB is equal to, I just want the camera to focus again quickly. There we go. Right, is equal to the square root of xb minus xa squared plus yb minus ya squared. So this is the formula. And when you start out working with these formulas and you're not very comfortable with them, it's a good idea to just write above every set of coordinates that you want to use here in the formula, write above it xy, xy. And then you can label them. You see the x and y at the A point. I'm going to label xa and ya. And at the B, I'm going to label this xb and yb. And this is going to help me to identify what I must substitute in here. So to substitute, I'm going to then find x value at B. It's this one, negative 2, minus the x value at A, which is that one, 1. All right, squared plus the y value at B, which is that one there, negative 7, minus the y value at A, which is negative 4. So there's a negative in the formula, and my y value is negative 4. Right, so I have a set of brackets around this, and then since I have a negative, I also have a set of brackets around that. That's why there's 2 brackets there, squared. Okay, and well, then you can just type this into your calculator. You don't really need to show further steps of simplification here. So I'm just going to type it into my calculator. I have a calculator on my phone that I can use. The square root of, that's -3. So -3 squared plus, and this is -3 as well, -3 squared. Now we did something weird. The square root of -3 squared plus -3 squared. There we go. I think that's better. Is 4,24. Okay, so then the answer is 4,24 units. Okay, the next question here, this is 1A. 1C is to determine the length between the points A -2, 1 and B 3, 13. So yet again, I'm just going to quickly write these coordinates here. -2, 1 and B is 3, 13. I apologize for the background noise there. Okay, right, so the formula AB is root of xb minus xa squared plus yb minus ya squared. Okay, if there's a c and a d, that's fine. You can just change these values then to cd and making that xd minus xc over yd plus yd minus yc. So you can change this as long as just keep the same letter first and the same letter last. Right, don't swap them. Okay, so yet again, just to make my life easier, I can just write there xy, xy above my coordinates, and then this is the point A, so this is XA and YA, and this is the point B, so this is XB and YB. Right, and then I'm going to substitute into the formula. So xb is 3 minus xa, which is -2 squared, plus yb, which is 13 minus ya1 squared. And I'm going to type this into my calculator. 3 plus 2 is 5, and 13 minus 1 is 12. Just to save me some typing on the calculator. I mean, you can type this exactly like it is in your calculator, but just to type a bit faster, I can type 5 squared plus 12 squared, and then that is 13. Alright, so, I shouldn't have made this now. Let me just scratch that. Okay, so then the answer is 13 units. Okay, that's the distance formula. Easy enough. You can try number B and D on your own there. Question 2 says, determine the perimeter of triangle ABC with A23, B3, -2, and C, -2, -3. So perimeter, I want to add the side lengths. If you think of a triangle, it doesn't really matter now where the coordinates are on the Cartesian plane, a triangle like that. I have A, which is given here as 2, 3, the point 2, 3. B, which is 3, -2. B, which is 3, -2. And C, which is -2, -3. Right? So to find the perimeter of this triangle, what I want to do is I want to add all of the side lengths. So I want the side length of AB, BC, and AC. So I'm going to use distance formula, distance formula, distance formula, which is what we've done here now. Yet again, to make your life easier, you can write above all of the coordinates XY, XY, and then this is XA, YA, XB, YB, XC, YC. Alright, so to calculate AB, I'm going to use XB minus XA squared plus YB minus YA squared is equal to, it's 3 minus 2 and -2 minus 3. squared, and then type this into your calculator. This is then root 26, which is rounded to 5.099. Then that rounds off to 5.10 units. So that's AB. And just to also show you how to adapt the formula with different coordinates, I'm going to do BC as well, like that. So BC, you see this formula, it's XB minus XA, YB minus YA. So I'm going to follow the same pattern, XC minus XB, XC minus XB, plus then YC minus YB. You see, it's the same formula, but I changed it now to C and B instead of B and A because I have another coordinate there. And then substitute xc minus xb is negative 2 minus 3 squared, yc minus yb squared, and yet again quickly calculator, and that's also 5.099, which is 5.10 then units if I round to 2 decimals. And in the same way, we're also going to calculate AC quickly. AC, which is then square root of XC minus XA. I'm not going to write the formula again because I know the formula. If you need to write the formula again, that's fine. I'm still going to substitute in there negative 2 minus 2 squared plus negative 3 minus 3 squared, and that gives me on my calculator, let me just quickly type it in here. It gives me 7.21. Okay, 7.211, which rounds to 7.21 units. Right, so now I have the lengths of AB, BC, AC, and that means then that the perimeter is equal to AB plus BC plus AC, which is then the 5.1 plus 5.1, 5.1 plus 5.1 plus 7.21 units. Right, 7.21 plus 5.1 plus 5.1. I'm typing it into my calculator quickly as well. And my calculator is doing weird things. Let me just try again. Uh, 17.41. 17.41. Okay, so units, that's the perimeter. That's question 2a. Then question 2b is show that triangle ABC is a right angle triangle, hint use Pythagoras. Right? Show that ABC is a right angle triangle. Now, Pythagoras works for triangles with a 90-degree in it. Pythagoras is that the two sides here is, when I square them and add them, gives me the square of the hypotenuse. A squared plus B squared is C squared for Pythagoras. So I worked out the three sides as 5.1, 5.1, and 7.21. So for question B, what I basically want to do is I want to check that 5.1 squared plus 5.1 squared is what? Check the one side of Pythagoras. It's 5.1 squared plus 5.1 squared, which is then 52.02. 52.02, and the other hypotenuse side, obviously since this one is longer than the other two, I'm going to assume this one is the hypotenuse, and then 7.21 squared is equal to 7.21 squared, I don't know if that's a comma there, is 51.98. Well, it's not exactly the same. 51.98, it's not exactly the same, which I need this to be the same, but I'm supposing that it's close enough for that to be a right angle triangle. The reason why this is not exactly the same is probably because I rounded these off. If you use the extended unrounded one values there, you should probably get the answer the same, even more so. So then you can say by Pythagoras, it is right angled. Right, I'm assuming here that this is 52 and this is 52, so I'm rounding off because I rounded off there as well, and that's fine. Okay, if you are a bit of a perfectionist and you need these closer to one another, just don't round those off, keep the numbers a bit longer and use them here, and you should get more accurate answers there. Right, let's look at question 2. I was quickly going to turn the page here. That was question 2. Question 3 is calculate the coordinates of the midpoint of the line joining the points. So there's the point AB, and there's two other points, P, Q, or S. I think let me do, I'll do number A and C again. You can do number B and D. So we want to calculate the coordinates of the midpoint of A, 1, minus 4, and B, minus 2, minus 7. That's question 3A. The A is at 1, negative 4, and the B is at negative 2, negative 7. So I'm going to label them again, X, Y, X, Y. And this is A, and this is B. And then the midpoint formula looks like this. The midpoint of AB, you can write it like that. Midpoint of AB is going to be XB plus XA over 2. This is the formula. You should know the formula. YB plus YA over 2. Right. So XB negative 2 plus XA is 1 over 2. And then YB negative 7 plus YA, which is negative 4 over 2. And then this is two separate things. And you're just going to type this into your calculator and type that into your calculator. So negative 2 plus 1, negative 2 plus 1 over 2 is going to be negative a half, negative 0.5, negative a half. And this is minus 4, right? A plus and a minus is a minus. So minus 7 minus 4. Minus 7 minus 4 over 2 is going to be negative 5.5. You can write it as negative 5.5, negative 11 over 2, or negative 5.5. Whether you write it as a mixed fraction, improper fraction, or decimal fraction, that's fine. Okay, so this is the coordinates of the midpoint between A and B is at negative half, negative 5.5. Let's do question C as well. Question C just gives me two coordinates, minus 2, 1 and 3, 13. Now, it's not labeled A and B here, so you can work with, so you can still label it A and B, their footnotes, or you can just label it as x1, y1 and x2, y2. And then I'm going to write the formula. The midpoint here is going to be x1 plus x2 over 2, y1 plus y2 over 2. So you see you can adapt the formula to whatever you have there. And then I'm going to do this. X1 is negative 2 plus x2 is 3 over 2, and y1 is 1 plus y2 is 13 over 2. You can use your calculator. I can see this is 1 over 2, so it's a half. and this is 14 over 2, which is 7. So a half 7 is the coordinates of the midpoint between these 2 points. Easy enough. Last thing, we're going to quickly just do 2 gradients. I'm going to do A and C again. Let me do C and E, because you see there's something weird going on there. So I'll do C and E because E is funny, and then you can do A, B, and D on your own. So C, -5, 1, and -5, 6. So now I want to find the gradient. The gradient here, 1, -4, and -2, -7. So yet again, x, y, x, y, and you can label it anything, A, B, this is point A now, and this is point B. Since it's not labeled, you can just call it something for the purposes of the formula. So the gradient of AB, you see the midpoint, I use a capital letter M for midpoint and a small letter m for the gradient. So the gradient of AB, difference in y, so yb minus ya over difference in x, xb minus xa. Right, difference in y, -7 minus -4 over -2 minus 1. And yet again, don't bother too much with simplifying that in many steps. Just type that into your calculator. So I have -7 minus -4 over -2 minus 1. And it gives me 1. Great. Is that correct? That's -7 plus 4, which is -3 over -3. Yes. Okay, so that's 1. Okay, that's the first one. Oh, I did number A now. I wanted to do number C. Sorry, but let's look at number E next, that weird one, which is 2PQ is the 1 point, and the other one is PQ minus 2. Okay, right, so I'm going to call this XY, XY. This is A and this is B. So the gradient of AB is going to be difference in y, yb minus ya, over difference in x, xb minus xa, and then yb is q minus 2. Q minus 2, subtract ya, which is q, over xb, which is p, subtract xi, which is 2p. Right, and now I must just simplify this. On the top, q minus q are like terms, so I can, well, subtract them. Q minus q is nothing, so that will fall away. Then I just have the -2 left on top. And at the bottom, p minus 2p is -p. So same as a negative times a negative over a negative, also positive. So this is just then 2 over p, and I can stop there, leave it like that. All right, so that's basically what you learn in grade 10, distance gradient and midpoint formulas, and how to use them. In the next video, we'll look then at the next section of work in the textbook.